Hello everyone, in this video I am going to teach you how to search an element in a linked list. Before I have taught you how to search an element in array. Now let's see in linked list. There are two techniques of searching. That is, one is linear search and other is binary search. In array you can do both searching, linear and binary. But see, in linked list you can't do binary search. Only linear search is possible. Why? Let's see. Suppose see. Now let's take this is array. Now in array, this is suppose there are five elements in this array. Suppose 7, 8, 4, 7, 8, then 14, then 17, then 20. Like this, 5 elements are present. In binary search, you should find the middle index. This is the 0, 1, 2, 3, 4. Suppose let's say these are the indexes. Now in binary search, you should find the middle index. How you can calculate middle index? 0 plus 4 by 2. Lowest index plus highest index by 2, that is, it gives 2. So this is the middle index. This 2 is the middle index. This you can find in array, but in linked list you can't find the middle index. Why? Because in array all the addresses are in consecutive location. Consecutive means the address of 0th index is 100, then this is 104, then this is 108, then this is 112, then this is 116. In equal interval, plus 4, plus 4, plus 4, like that. In equal intervals, these elements are placed. But in linked list, the elements are not placed in equal interval. Suppose see, let's say this is the linked list. Now the address of first node is, let's say, suppose 100. Then this is 200, let's say. This is 500, let's say. And this is 600, let's say. Now see, in this plus 100, just you are adding plus 100, but here 200 plus 300, the difference is 300. Here difference is 100. 500 plus 100 is 600. There is not equal interval. It's not placed in consecutive location. The elements are not placed in consecutive location. So you can't find the middle index in this. If you add, see, 100 plus 600 is 700. 700 by 2 is what? 350. But 350 is not the middle index. So you can't find the binary search in this linked list. Only linear search is possible. That I will teach you how to search linear search in this linked list. There are two methods, iterative method and recursive method. I'll teach you first iterative method. See, now this is the linked list. This all are the addresses. This first node, second node, third node, fourth node. Now see, I'll store the data in all the nodes. Suppose let's say 7, 8, then 12, then 5. These elements are stored in linked list. Now see, these are the pointer part. This stores the address of next node. The address of next node is 200. So 200 is stored in here. Now 500 is the address of third node. It is stored here. Then here it's stored 600 because 600 is the address. Then 0 because no node is present after this. Now I have written a linked list and the head pointer is used to point the first node. First node address is 100. So 100 gets stored in head part. Now see, now suppose you want to search a key element, suppose let's say 12. Suppose no, let's say key element 5 in this linked list, whether 5 is present in this linked list or not. How to check? By linear search. See, iterative process. First you should take a pointer called temp. New pointer called temp. And that pointer should point towards the first node. First node is what? Head. Temp should be equals to head. So if temp is equals to head means temp equals to 100. Then this will point towards the first node. So this you should create a new pointer which is pointing to the first node. Now see, now you should check whether the data in this temp, now the address temp has, this temp pointer has the address 100. Now check the 100's data. What is the data present in this 100 node? Address 100. The data present is 7. Now you should check whether 7 is equals to 5 or not. If it's not equal, so you have not found. So now what you should do? You should move this pointer to next node. How you can move this? You should change the temp the value in this temp pointer. You should change 100 to the 200. How you can change? Temp should be equals to temp next. Temp next is what? 100. Temp is 100. 100 next is 200. So the name of this pointer is next. So temp next is 100, next is 200. So this value changes to 200. So this pointer changes from pointing to first node, it changes to second node. Now see, now you will again check whether temp data, that is 200's data is what? 8. Whether 8 is equals to this key element? No, it's not equal. So I'll change the temp value. Temp equals to temp next. Temp is 200, 200 next is 500. So I'll change this value to 500. So this pointer will point towards this thing. Now it checks the data in this temp. Now temp is 500. 500's data is what? 12. Now it checks whether 12 is equals to this key. No, it's not equal, it's 5. So you should move to next node. How you can move? Temp equals to temp next. Temp is 500. 500 next is 600. So I'll change this to 600. Then this pointer will change to this location. Now I'll check whether the 600's data, that is 5, whether 5 is equals to this key element. Yeah, it's equal. You have found the key element in this linked list. So you should print true. That is, you should print true. If you have found the element in linked list, means it returns true. If you not found, means it returns false. Suppose see, instead of 5, suppose 7 is here. Then you have not found the key element in this linked list. So again it will move 600. This value will change to 600 next. This 0. Now 0 means it will not point to anything. After this it's not that. So you have not found any element, this 5, you have not found the key value 5 in this linked list. Then you should return false. So now this is the process linear search. Now I'll explain you how to write the code. See, now this was 5, and now see, now at starting this temp is pointing to first node 100. So I'm writing the C. Now I'll write the function bool search, then pointer head pointer. Now this is the function, searching function. Bool is, it returns true if it is found. If it's found means it returns true. If it's not found means it returns false. Now see, this is the function, searching function. This is pointer head. Head is used to point the first node. Now this symbol is used to represent pointer. Now see, this is key. This key is the element which you should search in this linked list. That is 5. Now see, I'll write. Now at starting you have created a temp pointer which is pointing to first node, that is head. So I'll write here, see, pointer temp. This pointer temp is pointing to a node. So I'm writing temp pointer is pointing to a node. That temp pointer is pointing at which node? First node. That first node is what? That address of first node is what? Head. Head is pointing towards 100. So you should write equals to head. This is the first step. Now see, now you should check. See, now you are checking whether this temp is pointing to first node. You are checking 100's data, that is 7. Whether 7 is equals to 5? No. That I am writing the condition. If temp data equals to key, you are checking whether 100's data 7 is equals to 5. If it's equals to 5 means, suppose if here 5 is present, if you found the key element in first node itself, then you should write C, return true, that is you have found. Or else if you have not found means what you should write? You should move the temp pointer to next pointer, next node. How you will change? Temp equals to temp next. 100, temp is 100. 100 next is 200. So you will change this value to 200. So it's pointing to second node. So I am writing else temp equals to temp next. Now see, now I have moved. Now again I will check. I should go back to same condition. Same, I should go back and check whether this 8 is equals to 5. I should go to this step. How I can go? So I should write a while loop. See, while temp not equals to null. That means see, this while temp not equals to null means it goes, see, it goes till now it's 200. Then it checks the data. If it's not equal means it moves to 500. This will be 500. Then it checks whether 12 is equals to 5. No. Then it moves to this step, 600. Now again it checks, suppose instead of 5 here 7 is there, then it checks whether 7 is equals to 5. No, then this temp value changes to temp data. Temp is 600, 600's temp equals to temp next, 600's next is what, 0, so this value changes to 0. Then this pointer will point to next node. There is no node present after this, so this is 0 till this. That's why I'm writing while temp not equals to null. Now temp is null, so at this stage it does not enter into this condition. There is no node present after this, so you can't find the data in that. You can't find the data in unpresent node, so it does not enter into this condition. If you don't find any element in this linked list, means if you don't find the this key element in linked list, means you should return false. So I'm writing here, see, return false. So this is how you should write the code for iterative process. Now I'll teach you how to search an element using recursive method. In recursive method, before in iterative method we have created a pointer called temp, but in recursive method no need to create a new pointer called temp. This head pointer is enough. Now see how I'll write. First I'll write this bool, same function, bool search, then pointer head, that is pointing to node, comma, int key. This key is the element which you should find. Now see, now first this head pointer is pointing to this first node. Suppose let's say there is no element, no node is present in this linked list. This linked list is empty. Suppose that means if it's empty, no node is present, means this head pointer will point to head value will be 0. So if 0 means it's not pointing, no node is present. So I am writing that condition. See, if head equals to null, that means 0. If head is pointing to 0, that means no element is there in linked list, means you should write false, return false. Why you are writing? Because if no element is present in linked list, means you can't search a key element into that linked list, because linked list is empty. So that's the condition, return false. Now see the next condition. Now this is pointing at 100, first node. Now you will check. See, first you will check head data, that is 7. The data part of first node, that is 7. You will check whether 7 is equals to this key 5. It's not equal, so that condition I am writing. See how you can access the data part, head data. So I am writing, see, if head data equals to key, if it's equal, suppose the 7 is equals to 5, means suppose instead of here 5 is there. If you have found in first step, means then you should write, see, return true. That means you have found the key element. If it's not found, suppose here 7 is there, then this 7 is not equals to 5, then what you should do? You should move to next node. How you can move? So see here, I am writing else. Now see, now this head pointer is pointing to first node. Now you should point it to second node. So how you can point? I should change the head value to address of second node, that is 200. I should change 100 to 200. How I can change it? I should change head equals to head next. See, head is 100, 100 next is 200. So I'll change 100 to 200 now. Head equals to head next. Now if I change this value 200, 100 to 200, then this pointer will point towards second node. Now again I will check. It again goes back and it checks whether if head data equals to key, that is whether 8 is equals to 5. So now I should move this pointer to next node. So I am writing a recursive function. See, I should write the same function, this search function. See, else return bool. First head was pointing, head was 100, so it was pointing at this node, first node. Now you should move to second node. Second node means head value should be equals to head next. Head next is 200, so 100 will change to 200. So I am writing, see, this head, instead of head, this parameter searching, the searching function takes parameter head. Now in this next step, I am changing that head parameter to head next. See, head next. So head next is 200. So now 200. So this will be 200. Now 200 is the, it will go back to same function, search function, and 200 will be entered here. So now 200 is the head value. Now it checks whether 200 is null. No, 200, it's not null, it's not 0. Some node is present. So it will check heads data, that is 200. 200's data is 8. So it checks whether 8 is equals to 5. No, it's not equal. Then it goes into this condition. Return bool search head next. Now head is 200. 200's next is 500. So this 500 it will change. See, it will go back to same function, search function, and here head will be 500. So this is how now this pointer will point to this thing. So this is how you will write the code for recursive function. Then that's all for today, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.